Now, you are welcome to lesson 3 of this tutorial, and like I said at the beginning, so lesson 3 is on t-test, and the precursor to this is the sample variance that we just did in lesson 2. So we need that for this lesson 3. However, I need to clarify certain things from questions some of our colleagues have asked in the physical tutorial classes, and that is the fact that how do we identify the particular test we are supposed to carry out or we are supposed to do for a given question. How are we sure that this particular question should be solved with t-test, or this particular question should be solved with correlation, majorly t-test and correlation? Chi-square, there's no really any bone of contention on chi-square. So how do we make sure that we use the appropriate method? Yes, it is very simple, and we only need to pay attention to this. If you notice these questions, or even the ones that were solved by our amiable Professor Akolade in the EDU 711 class, you will notice certain things in those questions, and that is where I want to give a clue on how to determine what test in particular you are to carry out. Yes, basically two things are peculiar to those questions. Number one is grouping. Number two is tests. Because you will be told in some question that so person carried out a test on his or her students, and the results are as follows. So, and the grouping is also there. So maybe, for example, when we say PGD students, that is a group. And when we say EDU 711 test, I mean the results of PGD students in EDU 711 test. So in that case, the group is PGD students, and the result of the test, the test is EDU 711 scores. So to now determine which one to use, whether t-test or correlation, you have to take note of these things, these two things. In a case where you have two groups, let's maintain this test, for example, two groups, and those two groups, let's say we have PGDE part-time, and we have PGDE full-time. Both of them were given EDU 711 tests. So this is the grouping, and this is the tests. In this case, you have two groups and you have just one test. This grouping could also be done or be achieved in another way. For example, say PGDE male PGDE female, and so on and so forth. It could be PGDE single, PGDE married, and so on. So these two groups were given this same test. So it means this is group, this is test, this is also group. So I'm just writing this to show that to not restrict your thinking about the grouping to part-time and full-time. It could be anything. The basis is that you have two groups. That okay, this is group A and this is group B. Group A could be group of married students. Group B could be group of single students. Group A could be group of male. Group B could be female. Group A could be part-time. Group B could be full-time. Group A could be those PGD students who had their undergraduate in UNILAG, while Group B is those who did not have their undergraduate in UNILAG. So it could be it could vary as much as possible. So, but you have two groups. Then a single test is assigned to them. So in this case, what you need is t-tests. What you will do in this case is t-test. But in a situation whereby you have let's say let's say this. Okay, let's say study habits. Study habits inventory. That is SHI, study habit inventory, and EDU 711 tests. These two were administered to PGDE students. So in this case, this is the group and this is the test. So you will notice that here, unlike here where we have two groups, group 1 and group 2, here we have only one group, which is this. Unlike here where we have one test, here we have test 1 and test 2. So the test here could also be that, let's say EDU 711 tutorial attendance or class attendance, and EDU 711 tests. So both of these were administered to PGD students. That is, we have a record of how many of them who attended EDU 711 tutorial or EDU 711 class, and we have their test score as well. So for the PGD students. So this is also tests. So we have 1 and 2. This is 1, this is 2. So in this case, where we have 2 tests and 1 group, 2 tests and 1 group, then the ideal test here is correlation. Is what? Correlation. That is the ideal test. So in summary, when you have 2 groups and 1 test, you know that what you are expected to carry out is t-test. But when you have two tests and one group, then no doubt about it, you are expected to use correlation. So take note of that. It's very important. So I believe we have been able to resolve that uh, recurring question, that how do we identify what tests we are to use or what formula we are to use. So know that when you have two groups and one test, then your t-test formula. But when you have two tests and one group, then your correlation formula. So now I would like to take, I have cleaned the initial variables for x and y because I want us to use an example, maybe in past questions, in some of the past questions, for the example to solve for t-test. And the reason is not far-fetched. You will notice that in most of those questions that we have solved for that we have in the past question for t-test, we even some of the ones that Professor Okoli did for us in the class, we had to mention, we were asked to generate a appropriate research question and appropriate research hypothesis, then test it. So that is why we want to look at those questions. So let's see one of them you can use here. Sorry, I'm searching for the question. Okay, I think I found one here. Yeah, this is 2024. Okay, this is class test for 2024 part-time. Okay. Okay, let me keep this for correlation. The t-test here is not the straightforward one, so let's keep that for now. Yes, we have this. The question says a postgraduate student, let me put it down somewhere. A postgraduate student administered the scholastic aptitude. The scholastic aptitude test. to a random sample of 24 SS1 students. From two school type. And obtained the following score. So we have the score to be public, that's school type 1. For public, we have we have 68, 72, 58, 52, 50, 45, 80, 57, 42, 60, 68, and 60. Then for private, we have 33, 53, 40, 43, 45, 59, 46, 55, 56, 40, 45, 52. So check if they are complete. They must be the same number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So now, the first question is state the appropriate research question. Roman figure 1. State the appropriate research question. For the data. Roman figure 2. Formulate a suitable null hypothesis. For the data, test it and conclude. Yeah. So that's the question. So all of this, the first thing, like I said, you check how many group, how many tests do you have. A postgraduate student administered the scholastic aptitude test. That is the only test that we have here. That is one test. To a random sample of SS1, 24 SS1 students from 2 schools. So this from 2 school types has shown that you have 2 groups here. And that is why you have public and private. So here, it means we have 2 groups and 1 test. And that is what? T-test. So take note of that. That is surely going to be T-test. Then, you are asked to state the appropriate research question. Appropriate research question. One thing you need to know is that when you are dealing with T-test, you are particular about the difference between the 2 groups. The difference between what? Between the 2 groups involved. But when you are dealing with correlation, you are concerned with the relationship between the two tests. Let me come again. T-test is difference between the two groups, and correlation is relationship between the two tests. Difference in the sense that when we say this is group A and this is group B and they both have a test, then we want to see whether the score of group A is different from the score of group B in that same test. That is for t-test. But for correlation, a single group had two tests. Then we want to see, is there any relationship between the first test and the second test? So that is what we need to formulate our question and research hypothesis. So the question is a very simple thing. Just formulate a very simple question. However, note that your question should not be a yes or no question. That is, it must not be such a question that a yes can answer it. For instance, we know that we are looking for difference between public and private school. Now, a question is there any difference? Or even when you say, is there any significant difference in the scholastic aptitude test of SS1 students in public school and their counterparts in private school? Then I can decide to say a yes to that answer, to that question, that yes, there is. No, there is not. So I always avoid such question. Instead, what you should ask, so let's start our solution here. What you should ask is this question, that's research question. You say, what is the difference between the scholastic aptitude tests of SS1 students in public and private schools? In public and private schools. So this is a very good question. You can see that a yes or a no cannot answer this question. You have to be specific. What is the difference? Oh, the difference is 1. The difference is 10. The difference is this. So question mark here. Then your research hypothesis, and that is null hypothesis, H naught. Like it was stated in the question, formulate a suitable null hypothesis. Note that even if the question did not say null hypothesis, you must always formulate a null hypothesis. Take note of that. So when you are formulating a null hypothesis is just like answer this question in a negative way. That will give you your null hypothesis. This question you have said that what is the difference between the scholastic aptitude test of SS1 students in public and private school. Just turn it to a negative answer by saying there is no, then you now bring in significant. That word significant is very important. There is no significant difference between the scholastic aptitude test (SAT). Please note, in exam or question test, don't abbreviate. I have to manage my board, that's why I'm abbreviating, and also to save time. So, but don't abbreviate. There is no significant difference between the scholastic aptitude test of SS1 students in public and private schools. Full stop. So with this, we have crossed the first and second hurdle of the question. So the next is test it. So we want to test this hypothesis and conclude. So by testing, we need to test using the t-test formula. So now, to have our t-test formula, the formula for t-tests, so t-tests, so we represent it with t-car. T-car meaning t calculated, because whatever we calculate here, we are still going to get the critical value from the critical table. So we are going to get the critical value. So this is t-car. So our t-car is equal to m1 minus m2 all over square root of, because we are dealing with two groups, so the public school will be our x and the private school will be our y. So all over s square of x over n plus s square of y over n, and that is our t-test formula. That's our t-test formula. So m1 minus m2 over s square of x over n1, we can say n1 or ns, n1 s square of y over n2. So that is what we need to do. And like I said the other time, that our sample variance is a precursor to population variance. It is a precursor to t-test calculation. So in essence, you will see that here we have s squared. So it means we need to get the sample variance of s, and we have sy here. We need to get the sample variance of y. M1 and M2 is mean of x is M1, mean of y is M2. Then N1 is the total number of items we have here, which is 12. N2 is the total number we have here, which is also 12. So here we need this. So let's solve for x. Yes, let's solve for x. So let's say our x, let's have our table. We don't have a a large space, so we have to manage the table. So we have our x here, our x minus x bar, and our x minus x bar squared. So our x, so we need to arrange this in vertical order. So 62, 68, 72, 58, 52, 50, 45, 80, 57, 42, 60, 68, 60. Let's see if there's no mistake. 68, 72, 58, 52, 50, 45, 80, 57, 42, 60, 68, 60. Yes, that's correct. Now, the first is to get our mean. That is addition of this, that's summation of all this, divided by n, which is 12. So let's pick our calculator. We have 68 plus 72 plus 58 plus 52 plus 50 plus 45 plus 80 plus 57 plus 42 plus 60 plus 68 plus 60. That is equal to 712. 712. But we need to cross check to be very sure that there is no mistake in this calculation. And the simplest cue here is that add the last digit, all the last digits, add them together. Whatever the last digit of the addition of these last digits must give us 2. Let's see. 8 plus 2 plus 8 plus 2 plus 0 plus 5 plus 0 plus 7 plus 2 plus 0 plus 8 plus 0. Of course, we can skip the zeros. So that gives us 42. 42. So you can see with 42, the last digit is 2, which is what we have here. So it shows that it's an indication that we are on the right track. So now divide this by 12. 712 divided by 12, that gives us 59.3. So our x bar is equal to 59.3. 59.3. Yes. So now we need to subtract this from this. 68 minus 59.3 is equal to 8.7. 72 minus 59.3 is equal to 12.7. 58 minus 59.3 is minus 1.3. 52 minus this is minus 7.3. 50 minus this is minus 9.3. 45 minus this is minus 14.3. 80 minus 59.3 is equal to 20.7. 57 minus this is minus 2.3. 42 minus this, 42 minus 59.3 is minus 17.3. 60 minus this is 0.7. 68 minus this is 8.7. 60 minus this again, 0.7. Yes, there's another clue here that you can easily detect whether you are on the right track or not. And that is the fact that if you notice these values, it switch between minus and plus. So wherever it is plus, all the areas where you have plus, you are going to be having the same last digit. Here it is 7. Then every other one that is plus must be 7. If it is not 7, as in 0.7, if it is not 0.7, then there's a mistake somewhere. So check all through. This is 7. This is also plus, which is end with 7. This also plus. They all end with 7. Then the minus, we always end with the same last digits of the decimal of the mean. And we are talking about mean in decimal number now, in decimal places. So this is 59.3. So those ones in the negative must end with 3. That is 0.3. And let's see, this. They all end with 0.3. So take note of that. Now let's do the square. So like we said, the last digit here are 7 and 3. So in essence, we want to start checking while we are calculating whether we are correct or wrong, not until we finish everything. And the way to check, like I said in lesson 2, is that the last digit 7 here, the square of 7 is 49. So whenever you square any number with 7 here, all the positive number here, if you square them, the last digit must give you 9. If it doesn't give you 9, then there's a mistake somewhere. All the negative number here, they all end with 0.3. 3 raised to power 2 is 9. All of them must also end with 9. And now it means all of the value here must end with 9. And that also corroborates the other clue I mentioned in the other video, in the lesson 2, that whenever you are having decimal numbers here, your square here, all of them must end with the same number. And in this case, they must all end with 9. So let's go. 8.7 squared, that is 75.69. 12.7 squared, 161.29. 1.3 squared, 1.69. 7.3 squared, 53.29. 9.3 squared, 86.49. 14.3 squared, 204.49. 20.7 squared, 428.49. 2.3 squared, 5.29. 17.3 squared, 299.29. 0.7 squared, that's 0.49. 8.7 squared, we had it earlier, so that's 75.69. And 0.7 is 0.49. So let's add them together to get the summation. So adding them together, like I said, if you notice, they all end with 9. So that is 9 multiplied by 12. We have 12 of them. That's 108. So our final answer here in the summation must end with 8. Let's see. 75.69 plus 161.29. Sorry, again. 75.69 plus 161.29 plus 1.69 plus 53.29 plus 86.49 plus 204.49 plus 428.49 plus 5.29 plus 299.29 plus 0.49 plus 75.69 plus 0.49 gives us grades 1,392.68. So that is the summation. So now let's do for y. So I have to clean that side, but before that, let me note the y value, the private, somewhere. So this is 33, 53, 40, 43, 45, 59, 46, 55, 56, 40, 45, and 52. Let's check. 33, 53, 40, 43, 45, 40, 59, 46, 55, 56, 40, 45, 52. Yeah. So you can clean this to get our y. Yeah. Sorry. So now let's get our y. This is y minus y bar, and y minus y bar all squared. So 33, 53, 40, 43, 45, 59, 46, 55, 56, 40, 45, and 52. So the first is to get our mean. Our y bar is equal to 6x bar. So addition of all this. So like we did the other time, to check if you are going to get the right answer. 3 plus 3 plus 3, that's 9, plus 5 plus 5 plus 9 plus 6 plus 5 plus 6 plus 5 plus 2 equals 47. So whatever we are getting here, 47 must end with 7 as a sum. So let's go. 33 plus 53 plus 40 plus 43 plus 45 plus 59 plus 46 plus 55 plus 56 plus 40 plus 45 plus 52. The answer is great. 5, 6, 7 divided by 12. that is 47. So our y bar equals 47 point, approximately 0.3. 47.3. Yeah. So now let's go. So by this, it means all the positive value we are going to get here must end with 10 minus 3 is 7. Must end with 7. While the negative value must end with 3. So just like we had for x. So 33 minus 43, 47.3. 33 minus 47.3. That's minus 14.3. 53 minus 47.3 is 5.7. 40 minus this minus 7.3. 43 minus this minus 4.3. 45 minus 2.3. 59 minus 47.3 is 11.7. 46 minus this minus 1.3. 55 again. 55 minus 47.3 equals 7.7. 56 will be 8.7. 40 is minus 7.3. 45 is minus 2.3, and 52 is 4.7. So the square of this. So the same thing here. All of these must end with 9 because 3 square is 9. So 14.3 square must end with 9. 7 square is 49, which end with 9. Hence 5.7 square must end with 9, and ditto for others. So let's go. 14.3 squared is 204.49. 5.7 squared is 32.49. 7.3 squared is 53.29. 4.3 squared is 18.49. 2.3 squared is 5.29. 11.7 squared is 136.89. 1.3 squared is 1.69. 7.7 squared is 59.29. 8.7 squared is 75.69. 7.3 squared is 53.29. 2.3 squared is 5.29. And lastly, 4.7 squared is 22.09. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So the sum. And the sum, again, they all end with 9. And 9 times 12 is 108. So the sum must also end with 8 as the last digit. So let's see. So if you don't get 8, then something is wrong somewhere. 204.49 plus 32.49 plus 53.29 plus 18.49 plus 5.29 plus 136.89 plus 1.69 plus 59.29 plus 75.69 plus 53.29 plus 5.29 plus 22.09 equals great. So we have 668.28. That's the summation. So now let's go back to the formula for T cap. Now we have our M1, which is 5.3. We have our M2, which is 47.3. We have our N1 and N2, which is 12 respectively. And now our S square of S is what we need to get. So here, from the sample variance formula, S square of S will be equal to summation S minus S bar squared all over N. N is 12. So in essence, this will be equal to summation S minus S bar squared is this 1392.68 all over 12. Now to avoid confusion, let me put it here. 1392.68 over 12. What does that give us? 1392.68 divided by 5 divided by 12. That gives us 116.05, okay, approximately 0.06 approximately. Then our S square of Y is summation Y minus Y bar squared all over N, which is equal to our summation Y minus Y bar squared is this 668.28 divided by 12. 668.28 divided by 12. That gives us 55.69. Great. Now we have all the variables in this formula. So let's go and slot it in. So our theta equals to m1 minus m2 over square root of x square of y over n1 plus x square of y over n2, and that gives us our m1 is 59.3 minus m2 47.3 divided by square root of our x square of s is this 116.06 divided by 12 plus x square of y is 55.69 divided by 12. So we can either get the solve this divided by this, then add it to this divided by this, or since they have the same base and it is plus, or if it is minus, you just say take the base, take the denominator which is 12, then add this and this together. But to save time, let's just get this and get this, then add 59.3 minus 47.3 is 12. So we have this equal to 12 divided by square root of 116.06 divided by 12. That gives us 9.67 or 672 plus 55.69 divided by 12. That gives us 4.641 approximately. Now this is equal to 12 divided by square root of 9.672 plus 4.641 is equal to 14.313. This is equal to 12 divided by square root of 14.313 is what? Square root of 14.313. 3.783. So 12 divided by 3.783 is, so our theta is equal to 3.17. Yeah, let's stop there. 3.17. Great. So this is our theta. So we can see it's straightforward, and you only need to keep checking and checking to detect if you are on the right track or not. So the moment you check and you are sure that you are on the right track, then you get to your final destination. So this is an aspect of the question, that is test the hypothesis. So to now conclude, we need to check the critical table. So this is the critical table. So, and you are checking from the one shared with us by our amiable Professor Okoli. So we are using the first table for t-test. You will see on it critical value of t. Yes, critical values of t. So now we need degree of freedom and we need level of significance. Our level of significance is usually 0.001 0.05. So take note of that. Whether for correlation, whether for chi-square or t-test, 0.05 is the level of significance we are using. So take note. Then degree of freedom for t-test. Degree of freedom, let me put that here. Our degree of freedom, df, is equal to n1 plus n2 minus 2. So this is 12 plus 12 minus 2, which is equal to 22. That's 24 minus 2, that's 22. So our degree of freedom is 22. So now, t-test is in the first table, first page. So check under 22 and trace it to 0.05. So I also need to explain something here. So if you notice, so this is our table. So you will see there, let me see if I can get a pointer. Yes, I think I have one here. Where are you, pointer? Yes. So this is my pointer. So this is our table for critical value. So you will see this is table critical value of t, which implies critical value of t-test. Then you will notice that here you have the first row here, level of significance for a directional one-tailed test, level of significance for a non-directional two-tailed test. Let me quickly explain that. One directional, which is one tail, is when you have a direct question or direct hypothesis, when your test is direct. For example, we are looking at the difference between public and private. If I say that there is okay, we are looking for difference between the two groups. If I say that public school this is scholastic aptitude test. If I say public school scholastic aptitude test is higher, note that, higher than private school scholastic aptitude test, that is directional. That is, I'm specific. So the same way I said it is higher, if I also say it is lower, it is still also directional because I'm specific. So that is directional, that is one tailed. So but if I say if I say there is no difference, or even if I say there is difference between public and private school scholastic aptitude test, it means it is non-directional. So there is difference could be that public is higher than private. Even when I say public school scholastic aptitude test is higher than private school scholastic aptitude test, so that is directional. But when I say public school scholastic aptitude test is different from private school scholastic aptitude test, that is non-directional. I'm not specific. It's different from it could be that it is higher than it or it is lower than it. So that is totally different from when I'm particular about it and saying that it is lower or it is higher. So that's the difference between directional and non-directional. So directional is when you are specific, it is higher, it is lower, that is one thing. Non-directional is when you are not specific, you are just asking about the difference. What is the difference? Is there any difference? It is different from this. That is non-directional and that is two-tailed. Yes, that now affects our that now determine what table will be used. And when you are setting this question yourself, an hypothesis like the one we are solving, always use a non-directional hypothesis or a non-directional test. Don't mention whether it is higher or lower, just talk about the difference. So now when you look at this, we have one tailed here and we have two tailed here, and you will see that when we have one tail, under it we have the level of significance. 0.1 here, 0.05 here, 0.025 here, 0.01, 0.005 and 0.0005. Under here we have level of significance for non-directional two-tail. We have that one starting from 0.2, 0.1, 0.05, 0.02, 0.1, 0.001. So you will now notice that under non-directional, okay, under directional, which is one tail, where you have 0.1, then for non-directional two tail we have 0.2. The same way we are using 0.05 for non-directional, which is here. If you notice, directional above it is 0.25. So if you are checking for non-directional at 0.05, you are checking this column, which is directly under 0.025 for directional. Now the implication of this is, if for instance you are given a table and you don't have it like this, like directional and non-directional, one tail and two tail stipulated here, maybe the table is just only one tail, and here you are testing your own under two tail. So when your own is 0.05 under two tail, just divide it by 2, that will give you 0.025. Then you can check 0.025 under two tail, under one tail, for 0.05 under two tail. So if you have a two tail, a one tail table, and you want to check for a two tail, your level of significance, just divide it by 2. If you have a two tail table and you want to test for one tail, just multiply your level of significance by 2. But we don't need to disturb ourselves about that. This is the table we have been given already, and we are going to be taking this table into the exam hall. Mind you, if you have written anything on your own table, kindly go and print another one or make photocopy from others who have not written anything on their table. Even when a table is rough like mine, but there's nothing written on it, then you can use it in your, take it to exam hall and use it. So but when your table, you have written formulas on it, or you have written anything on it that could implicate you, then I will advise you that you don't take such table to the exam hall. Just get another table and take it there. So now if you check here under 0.05, our significance, our degree of freedom here, you will see that it's 22, and our level of significance is 0.05. So just come here, this is degree of freedom, you see DF, degree of freedom, trace it up to 22, 22, we have it here, this is 22. Then trace it to 0.05. 0.05 under levels, under two tail, is the fourth column. Count one column, first column, second column, third column and fourth column. So let's just go to 22 and see what is there in the fourth column. This is 22, this is column 1, column 2, column 3 and column 4. That is 2.074, 2074. So 2074, it means our T critical is equal to 2.074. Yes. So to conclude, our conclusion, let me rub off this to write the condition for our conclusion. We call it decision rule. We call it decision rule for our conclusion. So the decision rule is that if T critical, T cal, that's the one we calculated, is greater than T critical, rejects null hypothesis H naught. But if T car is less than T critical, accepts null hypothesis. So in this case, our T car, which is 3.17, is greater than our T critical, which is 2.074. Therefore, we reject H naught. So rejecting H naught means that there is a significant difference between scholastic aptitude test of SS1 students in public and private schools. That is the end. Thank you. So, like I said, our t-tests, we need our sample variance to do our t-tests, and that is exactly what we have done. So, thank you. I wish you best of luck.